Hi everyone, this is Geeta NG from Sri Venkateshwara College of Engineering. Today we are going to learn about the topic typical convolutional neural network architecture in a deep learning neural network. Now let us see the contents. The contents are introduction, block diagram of convolutional neural network, CNN architecture, benefits of CNN architecture, and the conclusion. Let us see the introduction. Here in convolutional neural network architecture, it's specifically designed to process the data like structures and typically images. The mainly convolutional neural network architecture is designed for the to process the data like structures and typically images. Then it achieves this through the combination of special layers and work together to extract the main features and it make and classifications. Let us see the convolutional neural network architecture. This architecture consists of an input layer, convolutional layers, and pooling layers, and activational layers, fully connected layers, and output layer. Here, first, the starting stage of convolutional neural network architecture is the input layer. This is the starting point. Here we'll consider the raw data. It seems like an image with its pixel values. This image with its pixel values, this raw data will fed into the network. Then convolutional layers. In these convolutional layers, it is the heart of the convolutional neural network architecture. Convolutional layer, it is one of the heart of the CNN network, CNN architecture. These layers, they perform the core operation of an convolution. Then it will imagine a filter like example kernel and it slide across the input image and capture a specific features like edges or shapes. It will perform a filter and it will perform a filter on an image or an input data and it will capture the specific features like an edges or shapes. This filter learns the weights during training and it determines how much importance to give to an certain pixel combination. This decides during the training. Then the output of a convolutional layer it is the feature map and highlighting the presence of those features in the image. Then the third layer is pooling layers. In these layers down the feature maps, as usual convolutional layer also gives the output, it features the maps and it reduces the dimensionality of the data. Like how means it control the overfitting by reducing the number of parameters to learn and it make the network more translation invariant, meaning slight shifts into the input image won't distractly alter the output. It means the pooling layer also gives the feature maps and also it helps in reducing the dimensionality of the data, like by controlling the overfitting and by reducing the number of parameters. Then it also makes the network more translation invariant. It seems it slightly shifts the input image into it drastically alter the output. Then the fourth layer is output layer. Before output layer, we have activation layers and also fully connected layers. Here in these first activation layers, it means this layer introduce a non-linearity into the network. It seems convolutional layers by themselves, they produce the linear outputs and activation functions like it consists of relay. It seems RELU, rectified linear unit. It helps the network learn how more complex patterns by introducing a threshold. By introducing an threshold value, it helps the network to learn more complex patterns and also it values the below zero or set to zero or while positive values they remains unchanged. The next layer is fully connected layers. Here in fully connected layers, this is towards the end of the network layer. This layers resembles the traditional neural network layers. These previously extracted features from the convolutional neural layers are flattened into a single vector and fed into these fully connected layers. Here, the network learns to combine these features to make a classifications or predictions based on the task at end. Then the last layer is output layer. Here, the final layer, it depends on the problem you are trying to solve. In your output layer, we are going to solve the uh, main problem. Here, for classification tasks, example, identifying a handwritten digits, it might use softmax activation to output a probability distribution for each possible class. Here, This output layer, it final layer, it depends on the problem what we are trying to solve. Based on that, we are going to use in this output layer. For regression tasks like predicting the image depth, it might have a single neuron with an linear activation. This is the output layer. Then block diagram. Here we have the input input layer, convolutional layer, pooling layer, and an fully connected and an output layer. As usual, here we learned the input layer and also convolutional layer, pooling layer, and fully connected and output layer. In this block diagram, the data flows from the input layer through multiple convolutional and the pooling layers, followed by the activation layers. If the activation layers here, there is no activation layer, then it reaches the fully connected layers and the output layer. First, in this block diagram, the data flows from the input layer through an multiple convolutional layer and the pooling layers. Then it transforms into the fully connected layers and an output layer. This sequentially flow allows the network to progressively extract the features from low level to high level. It seems from low level edges or lines to shapes and objects representations. Next, benefits of CNN architecture. There are three benefits of CNN architecture here: feature extraction, parameter efficiency, and the spatial awareness. Firstly, feature extraction. Feature extraction means by design, when CNNs are automatically learning the relevant features from the input data and removing the need for manual feature engineering. This is the feature extraction. This is also called as tedious process. Then next benefit of CNN architecture is parameter efficiency. Parameter efficiency means here by sharing the weight across the filter elements and using an local connections. That means when we are sharing and weight across the filter elements and using the local connections, this CNN achieve a good performance with fewer parameters compared to an fully connected neural networks for image data. This is the parameter efficiency. In parameter efficiency, mainly it achieves a good performance with an fewer parameters than compared to the fully connected neural networks in an image data or any other input data. Then the third CNN benefit of an architecture is spatial awareness. This spatial awareness means here the convolutional operation preserves the spatial relationship between it preserves the spatial relationship between the pixels and making the CNN ideal for tasks where this information is crucial for a image recognition and segmentation. These are the benefits of an CNN architecture. Conclusion of an convolutional neural networks. Here, CNN is one of the powerful tools in and various image related tasks like an image recognition or image segmentation. By understanding this architecture through an block diagram, it provides us an fundamental foundational knowledge, and also this teaches us how networks extract the features and learns the representations and finally make the predictions. By stacking and combining these layers in different configurations, CNNs have become a driving force in the field of deep learning. By stacking and combining these layers in different configurations, this CNN have become a driving force in the field of deep learning. Thank you.